In this video, we're going to be looking at coset multiplication, and by the end of it, we'll realize that coset multiplication has some real problems. Again, I want to sort of set the stage by letting R be a ring, and S is going to be a subring of R. Again, a reminder that R mod S is just the set of cosets of S inside R. And what we want to do is we want to define a coset multiplication on this set of cosets as follows. And the operation is going to be A plus S times B plus S. Well, what I'd really like to do is just keep it simple and call it AB plus S. Now, the only question is this operation well defined? And what I want to do is I actually want to look at a specific example, and the specific example is going to illustrate that we have some real problems. So, an extended example. I'm going to let my ring R be the set of 2 by 2 matrices with real entries, and we're just going to shorten that to M22. And so this is the set of things that look like A, B, C, D in matrix form, where A, B, C, and D are all real numbers. And I'm going to let my subring be the set of upper triangular matrices. In other words, U is the set of matrices that look like A, B, 0, C, where A, B, and C are all real numbers. Now, it is straightforward to show. That U is a subring of the set of 2 by 2 matrices. And I would encourage you to stop the video and prove that to yourself using the subring criteria before you continue the rest of the video. So hopefully you did that. Here's why this is a subring. So if I let this matrix and this matrix, so let's see, I guess I'm going to actually call this guy DE0F. These guys are two matrices inside U. And what I want to notice is that if I look at their difference is still upper triangular, because it turns out that that's A minus D, B minus E, 0, C minus F, and that's clearly an upper triangular matrix. And if I look at the product, A, B, 0, C times D, E, 0, F, the product of those two matrices turns out to be, let's see, that's going to be AD, and then we're going to have AE plus BF, and we're going to have a 0, and we're going to have CF, and that is clearly also an upper triangular matrix. And so the subring criteria says that U is indeed a subring of our ring of matrices. Now, is our coset multiplication well defined on the set of cosets of U? And remember, the set of cosets is simply the mod structure, the set of 2 by 2 matrices modded out by U. So that's what we're going to look at here. We're going to actually look at a very special kind of example. So I'm going to let A1 be the matrix 1, 1, 1, 1, and A2 is going to be the matrix 2, 2, 1, 2. And what I want to note is that A1 minus A2 is 1, 1, 0, 1, which is clearly inside U, and that tells me that A1 plus U and A2 plus U are the same coset. And I'm also going to let B1 be equal to 1, 2, 3, 4, and B2 is going to be equal to 2, 3, 3, 5. And if I look at B1 minus B2, that's also going to be 1, 1, 0, 1, which is an upper triangular matrix. And so I also know that B1 plus U is equal to B2 plus U as cosets. So the question now becomes, is A1 B1 plus U equal to A2 B2 plus U? And to answer that question, all I need to do is I need to compute A1 B1 and A2 B2 and look at their differences. So let's actually do that. A1 B1 is, let's go back it up and just see what they are. We want to look at this matrix times that matrix. So A1 times B1 is going to be 1, 1, 1, 1 times 1, 2, 3, 4. And when you compute that, you're going to wind up getting 4, 6, 4, 6. And A2 times B2, let's again go review what those are. A2 is this matrix, and B2 is that matrix. So we want to copy those two things down. A2 times B2 is going to be 2, 2, 1, 2 times 2, 3, 3, 5. And when you do that matrix multiplication, you're going to get, let's see, we're going to get 2 plus 6 is 10, and we're going to get 6 plus 10 is 16, and we're going to get 2 plus 6 is 8, and then we're going to get 3 plus 10 is 13. And what I want to notice is that if I look at A1 B1 minus A2 B2, that's 4, 6, 4, 6 minus 10, 16, 8, 13, and that turns out to be minus 6, minus 10, minus 4, minus 7, and that is not upper triangular because this entry is not 0. And as a result, I know that A1 B1 plus U is not the same coset of U as A2 times B2 plus U. And hence, I know that A1 plus U times B1 plus U is not the same as A2 plus U times B2 plus U. And what that says is that our coset multiplication is not well defined on the set of cosets of U inside the ring of 2 by 2 matrices. Our next video will look at how can we fix this problem by making an additional assumption.